Hi, this is Paul Desmond. I'm in the Schneider Electric booth at the Data Center World Conference here in Orlando. And I'm with Joe Capes, who is Business Development Director for Cooling for the Americas for Schneider. So welcome, Joe.
Thanks, Paul.
So I just wanted to chat with you about some of the issues I've been picking up here at the event. And you and I have chatted before about what you're hearing. Just want to get your take on some of these issues. Okay. The first one was having to do with managing airflow in a data center, the supply and return airflow, and just trying to keep it consistent. What are some of the issues you're hearing about there?
Well, I think there's a lot of challenges in data centers, surprisingly so, as it relates to supply and return air paths. There's a lot of customers that are still hesitant to use containment. So, you've got air mixing between the hot and cold aisles. I think part of the reason why, if you look, for instance, at the co-location segment, is there's a lot of concern, whether it's perception or reality, about the flexibility or inflexibility of using hot aisle containment or cold aisle containment. I think a co-location site's a very dynamic type of data center environment, so it does present some challenges from a flexibility perspective. I think another component of that is understanding that if you have perimeter cooling units, let's say, that are located in a mechanical corridor, those units oftentimes are fairly far away from the actual IT load that you're cooling. So we have customers that have mentioned that they're suffering from not being able to get enough static pressure under their raised floor in the center of the data center, because that tends to be the point farthest away from the actual cooling unit. So some of the things to consider would be, is there an opportunity to shorten the distance of your supply air path, to shorten the distance of your return air path? Can you implement cold aisle or hot aisle containment to try to eliminate or mitigate the air mixing? But surprisingly, it's one of the more basic components of data center design, but probably still one of the most challenging.
Yeah, and with respect to hot aisle and cold aisle, I know that's been sort of a debate going on in the industry for a long time as to which one is better, but are there sort of rules of thumb where you should use one versus the other?
I think the positioning I would take on that is if you're operating an existing data center, oftentimes cold aisle containment is a little bit more flexible to accomplish. I think hot aisle containment probably is a better approach, maybe if you have a new build or a major expansion happening in your facility. I think realistically you're going to get a tremendous benefit of using either or. But if you're looking to implement an economizer solution and you want to try to elevate those return air temperatures, I think hot aisle containment certainly gives you probably the best bang for the buck.
All right. Another issue we're talking about, and you referenced this, people are skittish about raising temperatures. I know ASHRAE came up with some new guidelines a couple of years ago, and the temps are, I think, probably higher than what most people are currently operating at. So what's your guidance in that respect?
I think the good news is I've seen design engineers really start to move to about a 75-degree inlet air temp. Historically, we saw a lot of data centers at 68, 69, 70-degree supply air temp, which really does not afford much opportunity to drive efficiency. But at 75 on up to 81 degrees, which is the maximum recommended guideline from ASHRAE, you can really start to get some benefit of additional hours for economization. And I think also, when we look at perception, again, getting back to the co-location type of facility, oftentimes they have service level agreements where they have to maintain an 81-degree maximum supply air condition. Resiliency is another big concern. What happens if you lose water supply to your cooling tower, or what happens if you lose a primary path of power? A lot of data center owners are very concerned about the amount of thermal ride-through they have until they can start those generators and get their heat rejection systems and their indoor cooling units back up and running.
Yep. Yeah, another issue we've been hearing about is humidity and difficulty in controlling humidity, especially when you're using outside air cooling systems. Can you talk about ways you might be able to address that?
Well, I think what we're starting to see is we're seeing more and more customers taking humidity control out of the computer room air conditioning unit and going either with a dedicated dehumidification or humidification system. I think there's an economy of scale that you can achieve by going to a centralized or dedicated humidification system, which can be a benefit. You do lose some of the redundancy versus having humidifiers in each individual cooling unit. So it's a balance between whether you're trying to optimize your cost or whether you're trying to get maximum redundancy. I do think also with outside air, we see more and more issues and feedback from customers where they are struggling at times to maintain their humidity conditions in the facility. One customer I spoke to recently said that they had 3 times the number of days this year above 80% humidity outside air, which required them to actually bring in temporary dehumidification systems just to deal with that problem. So certainly a consideration whether you're talking about using traditional cooling units or outside air. We definitely, I think, are seeing a trend towards customers wanting to manage that in a centralized type of approach.
A related topic is economizer mode of operation for your cooling, and I know that's a topic you've been talking about here at the event. Can you just give us a thumbnail sketch of where economizer mode might be most appropriate for folks?
Well, I mean, in the North American continent, we're really talking about roughly, 38 to 40 states, other than really the southeast where you've got very warm, humid conditions. You can use an economizer anywhere in the world, really. If you look at EcoBreeze as an example, we designed that product around the worst possible conditions globally, which happens to be Abu Dhabi, and even in Abu Dhabi we can do 60% partial free cooling by using indirect evaporative. The other 40% comes from DX vapor compression. So, really it's a situation where an economizer can be used anywhere in the world. The question comes down to cost versus benefit.
All right, Joe, well, that's about all the questions I had. I appreciate you taking a few minutes here.
Thank you.